Hi everyone, I hope you're doing fine. We are today looking into infrastructure as code. So, how do we define our infrastructure as code and what is the benefit? One of the big benefit to have your infrastructure in code form is that you can throw away your infrastructure and redeploy it. Or if you, for example, we have our infrastructure currently for our MMORPG in the dev environment, and let's say we want to have some testing environment for the test team, then it's really easy if we parameterize this infrastructure as code to deploy a new environment for a test team or a QA team or whatever. And it's really easy to duplicate those environments and to throw those environments away and redeploy them, which saves a lot of money and is just great to have. Also, it's always a big question in projects when you have a project which runs for several years and you are not sure if you tried around with Azure, maybe created one or two storage accounts, and you don't know 1 year after that if you still need them, depending on how clean you have your resource groups and everything. Sometimes it's really hard to know, do we really need everything that we deployed as infrastructure in the cloud? And if you have infrastructure as code and you are very confident that you worked very clean there, then you can throw away the whole subscription, everything you have in Azure, and you can let your pipeline or your process, how you deploy your infrastructure, recreate the infrastructure, and you are sure that only things that you really need is in Azure deployed, and so you don't pay for something which you don't need. There are two major ways to deploy infrastructure in Azure. One is to use Terraform. This is the way we decided to do it. And the other way is to use ARM deployments. ARM deployments are supported by Azure out of the box. Terraform is a third-party application which does the deployment for you. One thing which I don't like about ARM is when you have a resource group, you can go to export template here on the bottom left, and then this will generate an ARM template for you. And what I don't like about ARM templates is they are very verbose. They have a lot of parameters and they always show all parameters. So there's basically no good default value with ARM, and they always have this very verbose parameters. I might need to black out some of the things that you see here because there might be passwords or something in there. It shouldn't be, but better safe than sorry. So for our little infrastructure, it's 382 lines of ARM deployment. And if we compare that to our Terraform deployment for the same infrastructure, it's 82 lines. So it's 1/4 of text that we have to maintain that we saved. That's one of the biggest benefits in my opinion for Terraform. The reason how Terraform does this, Terraform has very good default values. So if I don't provide something, Terraform will use the default value. ARM doesn't do that. In ARM deployments, you always have to give every parameter there is. So there's a downside with Terraform, and ARM deployment supports incremental deployments. So you give them everything and he's able to detect what is deployed in Azure and can detect an incremental update if that is needed. It also supports full deployment where it will destroy everything and deploy new. Terraform isn't able to detect by the resource group what is deployed and do an incremental deployment based on that. For Terraform, what we have is we have a Terraform state, and there's a state file where Terraform remembers what is deployed, so that we can do incremental deployments and Terraform will detect, okay, nothing has changed. I don't know, to be honest. I think there is a way to create this Terraform state based on the resource group. So there is a way to recreate the state and reverse engineer your resource group. But I'm not 100% sure. I've never done that. But if you always deploy with Terraform and you may let Terraform maintain the state file, then it's basically also incremental. But there's a little downside with that on Terraform side, but apart from that, it's in my opinion way better to use Terraform. In Terraform, you are able, when you deploy something, let's say we deploy a resource group in Azure is just a group of infrastructure or some metadata about your thing that you have deployed in Azure. You can basically group things together, which is called resource group. And I deploy a resource group here, which I just give a name. And Terraform always has the structure, I want to deploy resource. What resource is it? And I give this resource a name within Terraform. And here our resource group is named Kubernetes. And I'm able to, for example, my cluster is also named Kubernetes, and my cluster needs to know where it needs to become deployed. It needs to know the resource group name. And in Terraform, what I can do is I can reference the resource group Kubernetes and give me the name. And this way I can reference things that I have deployed. This also gives Terraform the ability to create a dependency tree to know what needs to deploy first and what do the others depend on. And when I do the same thing in ARM, it would work differently. In ARM, you would have to generate a variable and use this variable throughout the deployment. But let's say, for example, I deploy my Cosmos DB, and this Cosmos DB has output. So something which is only known after the Cosmos DB is deployed. Let's go to the Terraform documentation for Cosmos DB real fast. And if we scroll down, we have the outputs. Here it is. The attributes that are exported. For example, the primary key. What I could do, if I want to, I could create in Terraform in Azure Key Vault, and after the Cosmos DB is deployed, I could say Azure Cosmos DB.db because I named it db.primary key. I could use that as a variable within Terraform, and this will have the primary key of my data of my Cosmos DB. And in ARM you can't do that. What you have to do in ARM is you have to deploy with an ARM template the Cosmos DB. Then normally you write a PowerShell script to get the primary key from your database, and then you have another ARM template which has as parameter this primary key, and you give it in. And in Terraform you have this everything in one file, and you could deploy it, and it will just really work really well with with such things as getting secrets and everything out of those things without knowing that. Well, what I have done currently, which I might change in the future, but it's not mandatory for now. I have been to Azure getting the primary key by hand, and it's a secret in Kubernetes. But still, you have the ability to leverage those output things that are available only after deployment of the given infrastructure. And I think that's a really good benefit, because normally you have a key vault and you want to save everything in there, and you can do that. And it's quite easy. I mean, you create a key vault, and Terraform, if you are at this documentation, always gives you a really good examples in how to deploy things. Then you can just copy that, change a parameter here and there, and you have a key vault. And then maybe you want to have a secret. Then you have an example for a secret, which is here at the bottom line. And for the value, you can do easily what I just said. Let's say I have we could even copy this example. Let's go back to our Terraform, and I could copy this example down here and just replace things. For example, I want to have my game name, and then I like to have a key vault. Then my resource group is named Kubernetes. Do I have to give oh, that's the tenant ID, because it's using my Azure RM client configuration, which is great. Maybe I don't want a premium key vault, because I don't want it to be that expensive. Then let's go to key vault, and we can check what is available. It's standard or premium, so let's take standard. And let's give key permissions and everything. That's no big deal. DB secret. Let's call this also Kubernetes. So then we have our Cosmos DB primary key. And then we could do, like I said, we take the Cosmos DB account, and it's called DB if I remember correctly, yes. And then this is primary key. And this should work just fine. I could run that locally. You can, the Terraform is a two-parted thing. You need to initialize, which basically downloads the provider which we use. We use the Azure RM provider because we're working with Azure. And then you could do something which is called plan. Plan gives out the plan that Terraform will execute. It will show if it needs to change anything, or if everything is the same as a known state to Terraform. And apply is executing the plan. Basically, you don't have to create a plan. You can directly do apply, and it will apply it. And there's destroy, which destroys everything. I have variables which gets replaced inside my Azure pipeline. In the next video we will talk about the Azure pipeline. Let's just replace that real fast with something. And then we have Azure RM. Good idea. Terraform backend. resource group. RG, then we have the account name. In my pipeline, I give those things to Terraform via parameters. That's why that's not needed there. And the benefit of giving that per parameters is that I can override that per environment. We could create variables for that, but I think this will work now. So it has initialized, and if we do Terraform plan, it should create a plan that the key vault client ID, let's give it just one, it doesn't matter for now. Define that, which is fine. We can do that. So now it has detected that 3 things needs to be added and 1 needs to be destroyed. The reason why it needs to be added and destroyed and everything is because I changed client secret and everything, because I just put in something in there, and it has detected it needs to create a secret for our key vault, and it needs to create the key vault. And the Kubernetes cluster must be replaced because I've given other secrets. So it's one change, to be honest, not to destroy and then add. But that's basically how Terraform works. And if I do Terraform apply, it would apply that and change my infrastructure, which I don't want. Let me revert everything first. So we changed the variable names so that Terraform will be fine. We added this line for data, which we don't need, and then we added the key vault and the secret. So you can see how to use Terraform, and we have this, given this backend, these parameters, so it knows where to find the state. In our pipeline, like I said before, I give those state variables via the pipeline. Let me go to the pipeline Terraform execute, and there you see I give the parameters which we had to input by hand, which is basically the service account which our Kubernetes cluster is running with. And when I init, you can see I give the storage account, resource group name, container name, and key. I give them as parameters in, so that's why I didn't had to declare them in my Terraform file. This way I can have a Terraform file for each environment that I have, so I'm more flexible. And this obviously runs in our pipeline, and it's the infrastructure step. So the pipeline is public, so what you should be able to see this. And if you go to one of the builds and you go to infrastructure, then you can basically see what Terraform is doing. It's init and it's apply. And it has no changes most of the time because I don't change the infrastructure much. But I am able to one-click recreate the infrastructure or create other environments and clone the environment and everything. Also, what we are able to do is I have a parameter execute Terraform. When I don't run this, then when I don't tick this, my pipeline will execute only plan. And when I say this is true, then it does the apply. So that I can, if I change my Terraform, I can recheck if I really want to have those changes done to my infrastructure. So let's really check just real fast what our infrastructure look like. I will give a link to the Terraform documentation, and you can go around with that. Our infrastructure is really simple. We have Kubernetes as an Azure Kubernetes service. We have a container registry for our Docker images, and we have a Cosmos DB for our data. One important thing for our Cosmos DB, to save a lot of money, we want to have a serverless Cosmos DB because we are barely using it, and serverless basically costs 25 cents if you don't use it. And if you have a Cosmos DB deployed, let's go to Azure Calculator. If you have a Cosmos DB, let's remove everything and add a Cosmos DB. Then it costs $23, or for me, I want to have this in euro. For me, it's 20 euro. I have to pay 20 euro for Cosmos DB that I barely use, which is a lot. And if I change that to serverless, it's 21 cents. Also, one benefit of serverless is serverless scales with your load. So when I get DDoS attack, the price goes up. For West Europe, it's 26 cents. But Azure has DDoS protection and everything in place. Still, it's quite cheap for dev environments. For production environments, you might want to have pre-provisioned, because serverless, even though this is cloud, if something needs to scale, it takes some time. So it's not like you have 10,000 requests and it instantly will have the capacity behind it to work with that. You have your 1 million requests, it will scale up, and eventually it will be able to handle the load, but still there is some period of time that needs to go by for everything to scale to the capacity that you need. That's the downside with serverless. And for example, let's say you have a business that on Christmas has heavy load, then it's really good to have your provisioned. Then you can scale for Christmas 1 or 2 days when your load will happen. And with serverless, like I said, it might be too late when the load is coming, but it will scale eventually. So for dev environment, serverless is really great because it's really cheap. So in Terraform, like I said, we have our Kubernetes, our resource group first, then we have our Kubernetes cluster, we have our Cosmos DB, and we have our container registry. And then basically what you have to do is you go to the documentation. That's how I do it. And where's my documentation? Here it is. And you go, for example, to Cosmos DB, and I want to have a Cosmos DB account. Then you check, okay, I don't want a random number. I have a resource group already in place. Then I, most of the time, first of all, copy over this example. And then I fill out everything that I know. And you can see I removed a lot of things. I, for example, don't need failover. This is a dev environment. I don't care. If it's down, then a dev will handle that. Then aggregate pipeline and MongoDB. I honestly don't need MongoDB, but I've kept it in. And I want the capability serverless. So how do you find out how serverless is done? I basically search serverless in the documentation. And thankfully, it just says capabilities enable serverless. And then capabilities, there's already an example, and then name, and then enable serverless. That's what I did, and I have a serverless. And then consistency, we have to talk about Cosmos DB a lot to explain that. And then geolocations, I don't need too much geolocations. Here they have 2 geolocations. I don't need that. This is a dev environment. If the Cosmos DB is down, then a dev will handle that. It's not like there's production load on it. This is how I create my Terraform files, and then it's really fast. I mean, you go to Kubernetes cluster, which is Azure Kubernetes Services. Maybe search Kubernetes, Azure Kubernetes cluster, then you see this example, which is really short. And then identity, system assigned, do I need it? No. This is a managed identity. You can use it. I mean, it's a great feature, but I didn't use it for now. Maybe in the future, but you can add those later. I don't need a tag because I have everything in a resource group, but I tagged the development nonetheless. Maybe I should add tags here for the Cosmos DB also and for the container registry then, but okay. Then you have your node pool. What nodes do we have? I've kept it, and I have agent pool count configurable, which is 1 for now. And then you have to give it an SSH key because I want to have Linux machines. And if you have a Linux blog profile, you can give a username and an SSH key to SSH connect to your Linux machine. And then you have DNS prefix, the name of the cluster and everything. And the rest will do Terraform. And container registry is basically name, location, SKU, and admin enabled, true or false. And then you have a container registry. And it will create that for you. And you can easily throw everything away and save cost with that. I could delete the resource group and let Terraform recreate it anytime I want to. And for Kubernetes, they create the special resource group. This is done by AKS. This has nothing to do with Terraform, where it creates your resources for your Kubernetes cluster. What I recommend you do when you work with the Kubernetes cluster, if you don't need it and this is your dev environment, press the stop button. This will deallocate your machines, even though it's recommended not to do that with a Kubernetes cluster for all VMs. AKS in my case works fine with that, and this saves a lot of cost because in an AKS cluster the virtual machine is the main cost driver. Yeah, that's it for infrastructure as code, I think. Please leave a like, and if you have any questions, join my Discord or write a comment on this YouTube channel. And I really want to thank you, my patron Julian, for supporting me. Have a good weekend. Bye.